Okay, this is 6.1 lesson. We're going to be working with relations and mapping diagrams, which we've kind of already covered a little bit in the activities. So some of you will pick up on this really quick if you were comfortable with the activities. So once again, a relation is a pair of inputs or a pair's inputs with outputs. A relation can be represented by ordered pairs or a mapping diagram. So we're going to learn in this within this chapter that a relation is just where you've got X's and Y's, or if they use other letters, same difference, inputs and outputs. As we get further into the chapter, you'll find out that a function is a specific type of relation in which you only have one input to one output. Okay, a relation can have more than one output. So in this scenario down below in 1 and 2, we have both of these would be considered relations, although one of them would only be considered a function. So I'll kind of discuss that, even though it's kind of doing a little bit of pre-teaching. So it says list the ordered pairs shown in the mapping diagram. So here's our mapping diagram. Ordered pairs are just your X's and Y's. So you're basically pulling this information and putting it into a set of ordered pairs. Pretty easy. It's just we're going to review it really quick, and then you guys will be able to move on pretty fast. So list the ordered pairs shown in the mapping diagram. So we have for our input, which is our X, our output is our Y. I have 0, 12 would be my first set. My second set, I like to do the parentheses because it's more visual for me, is 2, 10, 4, 8, and 6, 6. Okay, there's my ordered pairs for that first situation. Okay, and number 2, we have inputs of only 1 and 2, but we have 4 outputs. Still the same thing. We're still going to go ahead. I've got 1, -1. I also have 1, -2. Okay, so just because there's only 2 numbers in the output does not mean that I'm only going to have 2 sets of coordinate pairs. There's actually 4 there. Okay, so now I'm just going to use a different color. I've got 4, -3, or not 4, sorry, 2, -3. And then I also have 2, -4. Okay, so we still ended up with 4 sets of coordinate pairs. Okay, so I'm going to go ahead and slide one out. You guys go ahead and try it, and then you can check your answer in just a couple of minutes. Okay, so same concept. You're going to list the ordered pairs that are shown in the mapping diagram. And on this one, we'll discuss really quickly the difference between relation versus function. So go ahead, pause your video, do your ordered pairs, and then check back in just a minute. Okay, so there are your sets of ordered pairs. You'll notice in letter B, I made a mistake right away because I was trying to go through and do it really quick, that I had accidentally linked 0 to the 1. So sometimes, like for me, you'll notice I went through and actually touched and followed my line. Sometimes you might need to do that. I'm a very visual person, and I noticed, I guess I should have taken the time to do that. So take note, we ended up with 4 ordered pairs in each set. So your output is always going to tell you how many ordered pairs there are. Not necessarily the input. So in letter B, we had 3 inputs and 4 outputs. Okay, in this scenario, this one would be considered a function as we get further into the chapter. The second one would just be considered a relation because we had more than one output to that number 2. Okay, so that's why it would not be considered a function, because there's more than one output. And you'll work more with that in section 2. Okay, so we're going to go ahead and move on to determining whether we have relations that are functions. So sorry, I meant to say in part 2 of this. Okay, so we're going to determine, so the important part is in order for a relationship to be considered a function, there can only be one output for each of these. So in other words, we can't have 2 arrows coming off of one of our inputs. Okay, so here's 1 arrow going to one output, 1 arrow going to one output, one arrow going to an output, and one arrow going to that same output. So in this situation, I have 5 and 12 that are both going to that number 10 output. Okay, so in this scenario, although that it's set up that way, it would be considered a function, even though there's two outputs. The whole part is there can only be one output going from an input. So I just can't have two arrows coming off of an input. So this would be considered a function. Although I have two of them going to the same output, we still only have one arrow coming from each input. Okay, so here we have one arrow. Here I have two arrows. As soon as I have two arrows, two numbers, two outputs coming off of an input, it is no longer a function. So this is not a function. Okay, and I know that's kind of confusing. Why can we have two outputs, but we can't have two inputs? You'll learn more as you graph why that is. But just in this short case where they're not asking us to graph, they're just asking us to look at these mapping diagrams. The key thing is just you can only have one arrow coming from each input. Okay, and okay, but we can have more than one. You can have more than one output as long as it's coming from a different input number. Okay, so that's it. I'm going to go ahead and make a separate slide for our designing of patterns. Actually, no, I won't. We'll go ahead and continue. I'm going to have you guys practice this one more time. So let me pull this one out. Let me erase this. Okay, so I want you to look at these two samples and determine which one's a function and which one is not. So key thing is looking at that input part. You can only have one arrow from each input. So go ahead, pause the video, identify which one is a function and which one is not. Okay, so the one on the left is not a function because you've got two outputs coming from one input. And the one on the right is considered a function because you only have one input going to each output.